Okay, finally a problem we can sink our teeth into. Okay, so we're going to exert 35 newtons to the right. Here's our 5 kilogram object that's just obligingly sitting on the plane, right? Now, in the previous problem, we actually got that the force of friction dynamic is 8.33585, right? And then we got that the force of friction static, the max force, was 23.0535. Now, suffice it to say that if we exert 35 newtons on there, and it's sitting still, right? Okay, that's bigger than this force, right? It's bigger than this one, it's bigger than this one, right? So it breaks those bonds. This guy is no longer relevant. It breaks those bonds and starts to slide to the right. Now that it is sliding to the right, this guy becomes relevant. Right, so now 8.3385 is that way. We're going to make this way to right is always positive. Okay, so let's make that positive. That makes that positive. This is negative. And now we can set up F equals MA, right? So wow, what was that? My forces are negative 8.3385 plus 35 equals 5.00 times A. We can figure this out, right? So turn this calculator on, parentheses, negative 8.3385 plus 35, right parenthesis divided by 5, 5.3323. Okay, so it's going to accelerate to the right, and it's going to accelerate at that rate. So there's our answer for C. Okay, so just remember that you got to look at these problems, okay? And we only have two problems. We only have two forces. We've got an applied force. Okay, this was positive because it was to the right. Since it's sliding to the right, the friction force is to the left and therefore negative. We put the forces in, set it equal to MA, solve for A. That's not so bad. Is that bad? That's kind of bad. It's tricky. It's a little bit tricky.